Hi, and welcome back to an episode of Mr. Emond Teaching Math. Today we're going to be continuing on in radical expressions and equations, doing lesson 2. So here we're going to be adding and subtracting radicals. And to do that, every once in a while we might actually have to simplify or look at restrictions on the values in the variables. So that's what we're going to be focusing on today. Let's get started. We know that a like radical is a radical that has the same radicand and index. So when we have a radical, there's an index here. So this has an index of 2. And if we were going to create another radical that's like it, it also would have to have an index of 2. But it also has to have the same radicand. So the radicand is what's on the inside here. So if this one has a radicand of 2x, and this one also must have a radicand of 2x for them to be alike. Now, what we are learning about here in this section is that only like radicals, like the ones above, can be combined when you're adding or subtracting radicals. So this is kind of important. What this says is if I was going to add or subtract these two functions. Now, be careful because like radicals just means that they have the same index and radicand. Remember, there's also coefficients. So let's say that there was these coefficients. So we have 4 times the square root of 2x and 2 times the square root of 2x. Well, let's look at these. If we have these, we can actually combine them. And the way that you combine them is all you need to really look at here are your coefficients. So here we have the coefficients of 4 and 2. So if we were going to combine them, do addition. What's 4 plus 2? It's 6. So 4 square root of 2x plus 2 square root of 2x is 6 square root of 2x. 4 square root of 2x minus 2 square root of 2x is 2 square root of 2x. So we can either combine them, add them, or subtract them. Let's do some of the work down here. Do they have the same index? Yes. They both have an index of 2. Do they have the same radicand? Yes. They both have a radicand of 3. So we can combine them. How do you combine them? You look at the coefficients. What's 7 minus 2? It's 5. So this one would be 5 root 3. Very easy. Do they have the same index? Yes. Same radicand? Yes. So we can combine them. What's negative 5 minus 6? Negative 11. And the rest of this stays the same, cube root 10. Good. Do they have the same index? No. This has an index of 2, and this one has an index of 3. So it's not possible. We cannot combine these because they do not have the same index. All right, let's look at restrictions on a variable. If a radical represents a real number and has an even index, so even index being a square root, when the index is 4, 6, etc. The radicand, so this inside part, cannot be negative. So let's say that the radicand was 2x. What this means is if the index was even, the radicand, so the radicand being 2x, cannot be negative, which means it has to be greater than or equal to 0. Let's look at this example. The radical, the square root, I can't erase that for now. The radical, the square root of 4 minus x, has an even index. So what that means is 4 minus x, because it's the radicand, has to be greater than or equal to 0. And the way you write that is you just write the radicand, 4 minus x is greater than or equal to 0. But remember, we have to isolate the variable. And the way you do this is with algebra. So we're going to add x to both sides, and we have 4 is greater than or equal to x. I prefer having my variable on the left, so if it were on the left, we have to flip this around, right, so that the alligator is being eaten by the 4, or however they explain it in elementary. I just flip it around to the other side. Okay? So x is smaller than or equal to 4 is the same as 4 being bigger than or equal to x. Let's scroll down a bit and look at these. Now, what's interesting is that when it comes to these functions, notice it only said that it matters when you have an even index. When you have an odd index like these, it said that there would be no restrictions. And why is that? The reason why is because let's first look at the cube root of 8. We know that's 2, right? We can check in our calculator. The cube root of 8, yep, it's 2. And what this means, because it's a cube root, it means 2 times 2 times 2 is 8, right? Or 2 cubed is 8. So that works. That's a positive, right? We weren't worried about this one. Let's look at this one, though. It's still the 8, so it's still going to be the 2. But then now there's a negative sign, and we're saying it's going to work somehow. So if I put that negative sign in here, what's negative 2 times negative 2? That's 4. What's 4 times negative 2? That happens to also be negative 8, right? And the cube root of negative 8 is negative 2. Watch. The cube root of negative 8 is negative 2. So that's why it works. If I had the square root of negative 8, well, when I make my parentheses and I try to square it, there's nothing that I could actually put inside of here that would equal negative 8, right? Or let's make something a little bit more obvious rather than 8. 8's a bad example. Let's do 9. Okay, let's do 9. We know that 3 squared is 9. If I put the 3 in there, well, no, that doesn't work. That does not equal negative 9. That equals 9. And if I put the negative 3 in here, this still does not equal negative 9, because negative 3 times negative 3 is still positive 9. There is no way to get that negative. So the cubic roots, or with indexes 5, works because the negative signs are alternating on the odd ones. So you can actually get negative numbers. And you will know when you made a mistake, right? If you did the square root of negative 9, your calculator is going to scream at you, watch, no, error. I don't like that. And so it's telling you this is a non-real result. It's error. You can't do it. And that's why we have to restrict our answers. All right. With that in mind, determine the restriction on the variable for each of these radicands. Give it a shot. Pause the video here, and I will resume in 2 seconds for you to check your work. 2, 1, resume. Let's go through the answers. So we're just going to take the inside here, 3 minus m, and set it greater than or equal to 0. Isolate the variable, add m to both sides, and you have 3 is greater than or equal to m, or just flip it around, m is less than or equal to 3. On this one, you have 2x plus 5 greater than or equal to 0. Subtract 5 from both sides, get that 2x by itself. And then we need to get rid of the 2 in front of the x, so we divide by 2. And you're left with x is greater than or equal to negative 5 over 2. And this one here doesn't have any restrictions. Why? It's an odd index. No restrictions. Let's add or subtract. So we started this off on the first slide. It was really, really easy. Let's make sure that we know what we're doing here. Remember, we're going to have to do some simplifying. It says right here, simplify the radicals and combine the like terms. So let's continue with what we were doing last lesson. 2 squared is 4, 3 squared is 9, 16, 25, 36. We're learning the fast way to do this. 49, 64, 81, and 100, right? We could do the tree method and stuff, but you're all really smart. You've been watching my channel and learning from me, so you know that this is the fast way. We like the fast way. Square root of 50. What can we break it down with? The 25. So we're going to go 25 times 2. Plus 3 root 2. This one we can't touch. Root 25, well, that's 5 squared. And we can remove this 5. So we have 5 root 2 plus 3 root 2. 5 plus 3 is 8 root 2. Excellent. We're going to do the same thing here. Negative, this is 9 times 3. Plus 3 root 5. And here we go. This one, let's say 16. Times 5? Yeah, 16 times 5. And 2, and this is going to be 4 times 3. So this one might be tricky, this root 80. If you're good at mental math, that'll kind of help you. But if not, take your 80 and divide it by your square factors, which we started off with. 80 divided by 16 is 5, right? So 16 times 5 is 80. You might want to use your calculators for ones that are kind of tricky like that. I'm going to not change this to 3 squared and this to 4 squared and this to 2 squared. I think we've done it enough. Let's just remove it. So now we have negative 3 root 3 plus 3 root 5 minus 4 root 5. And then this is going to be minus 2 times 2 root 3, which is 4. And we're going to combine like terms. So where are our like terms? We have the root 3 and the root 3. And we have the root 5 and the root 5. So let's combine those. Negative 3 minus 4 is negative 7 root 3. Positive 3 minus 4 is minus 1 root 5. And there's our answer. And let's box this one too for good measure. Okay, in example C, why does B have to be greater than or equal to 0? Let's scroll down. Why does C have to be greater than or equal to 0? Well, okay, this is going to be 2 root C minus, oops, okay, 2 root C minus 12 root C. This is negative 10 root C. Why does this C have to be greater than or equal to 0? Well, because it's an even index, right? This index is 2. And whenever we have an even index, we have a restriction on the domain. And that restriction comes from your radicand. So you're going to take your radicand, which is C, and you're going to set that greater than or equal to 0. And then you're going to isolate the variable, but it's already isolated. So why does C have to be greater than or equal to 0? Well, because it's an even index, and that's what you do. Your turn. I'm going to pause the video here, work these out on your own, come back in 3, 2, 1 to check your answers. Here we go. And I'm going to end the video here. You can go through the work on your own, check your solutions, make sure you're doing it correctly. I will see you next time for lesson 3 of radical expressions and equations.